In this video, we are going to finish the concepts of chapter 2. We will first look at the biological effects of radiation, and then we're going to proceed to look at radiation protection. Radioactive emissions contain a lot of energy, and they will interact with many atoms. The way that they affect health depends on if the type of radiation that a particular person is exposed to is going to be non-ionizing, which you can see some examples of it on or below the blue arrow that we have on the image in the slide, or if the type of radiation is ionizing, which is the examples that are below the red arrow on the slide. Now we're going to look at the differences between ionizing radiation and non-ionizing radiation. Ionizing radiation is defined as high-frequency radiation that has enough energy to remove an electron from an atom or a molecule. Upon this electron removal, what's going to happen to the atom or molecule is that it's going to become charged. It is known that ionizing radiation has enough energy to damage important biomolecules like DNA. The reason why DNA is so important is because it's the way that information it is stored in human cells and many cells that are found in biological system. And if these biomolecules like DNA are damaged, that can lead to mutations, and mutations may lead to the creation of diseases like cancer. Some examples of ionizing radiation include gamma rays, X-rays, some high-energy UV rays, and some subatomic particles such as alpha and beta particles. Humans may be exposed to ionizing radiation in one of the following three sources. First, we have natural background radiation. So radiation is something that we are normally exposed to because of the cosmic rays that are actually received in this planet just because we're part of the solar system. In addition, there may be radioactive elements that are normally present in soil, and that could be an example of how we are able to be exposed to radiation. The other type of radiation may be medical radiation. Medical radiation comes in the form of diagnostic X-rays and other tests. In addition, some types of diseases like cancer may be treated with radiation therapy. Lastly, there may be non-medical human-made radiations, and those can come from the workplace, at times from other sources. So there was an important study in 1962 that was actually studying how above-ground nuclear weapon testing was resulting in the exposure of radiation to humans. Now, not all radiation is going to be super severe, and in the way that things are being tested, all of a sudden that could result in these cancers that I just mentioned. Understand that there are certain types of imaging tests which are necessary in the medical field, can expose you to ionizing radiation. But when people are exposed to this type of radiation, they're actually exposed to low levels of radiation. And in the case of X-rays, as you can see the image on the right side, that is a type of ionizing radiation that it is utilized in order to look at the pictures of the bones inside of the body. Understand that, for example, other type of imaging tests like MRI or ultrasound exams do not utilize ionizing radiation. That is just a much different technique that it is used. So now that we observe the examples of ionizing radiation, let's look at non-ionizing radiation. Non-ionizing radiation is defined as low-frequency radiation that does not have enough energy to remove electrons or directly damage DNA. Some examples of non-ionizing radiation, as you can see, are going to be many things that we utilize in everyday life. Low energy UV rays, which we can perceive from the sun. Visible light, which is what allows us to distinguish colors in everyday life. Infrared, microwaves, radio waves are all forms of non-ionizing radiation. Now, to date, it has been at least suggested that these type of radiation are not known to increase cancer risk, but that is the data that we have up to date. Lastly, we are going to be looking at radiation protection. Radiation of high energy can penetrate farther into a tissue. So it is important to know that when people work with radioactive materials, sometimes you may see that if you go to the doctor's office or you go to the dentist or you're going to receive this type of imaging, you will see that there's different protective shields that are utilized on you or on the person that is performing the particular testing in order for everybody to be safe in these environments. So sometimes we see heavy lab coats, lab glasses, gloves, sometimes plastic or lead shields are utilized. Another indicator that you may see that a worker is working with radioactive material is that they actually have a film batch monitor that tracks down their total exposure to radiation. In table 2.5 in the textbook, we have listed properties of common ionizing radiation. And as you can see, it has alpha particles, beta particles, X-rays, and gamma particles. It tells you the distance that these different types of radiation travel. It tells you what is the tissue penetration that they have and which different protective shields can be utilized in order to stop them. Let's get started with alpha particles. So an alpha particle can travel a few centimeters through air. It stops at the skin surface. It's only dangerous if it is inhaled or if it's eaten. And the protective shield that can be utilized for an alpha particle will be paper or clothing. Beta particles can travel a few meters through air. It will not penetrate past the skin layer. But as a protective shield, we need heavy clothing, plastic, aluminum foil, or gloves. Next, we have X-ray. X-rays can travel through air several meters. It can penetrate tissues, but not bone. When you're trying to get protected from an X-ray, so areas that you don't want that exposure, you can use a lead apron or a concrete barrier. Lastly, for gamma radiation, that can travel through air several hundred meters. It fully penetrates the body. And in order to have a protective shield, you may use thick lead, concrete, or a layer of water.